Thank you. It's a pleasure to be here, and thank you for coming to my talk. So, I'm basically doing the product development in different roles in our decade. So, from a solo developer to a member of a team to a team leader to actually someone who does product development, and even to a stakeholder. And in an ideal world, you would get through the requirement gathering phase, where of course the customers would know exactly what they want to build. You then translate that vision perfectly to your team. Your project would be completed within the deadline, and customers would be happy without any last-minute feedbacks. I think that you all have had the similar experience, right? Well, no, it's not really how it goes. It usually at some point it looks something like this, and it's pretty hard to communicate vision directly of what you're trying to build. There have been quite a lot of experiments with development methodologies where the agile on the rise in the past decades, but sometimes it's not really even possible to have a clear vision because users or customers do not know what they want to build. Sometimes they want to explore with you. And I think that's a completely valid development model. Perhaps you're in a startup environment and you want to switch your product to a different market. Perhaps you even want to pivot. The thing is, in development, things happen. And we need a way to react to those changes. So, as project grows, we all know how change management becomes hard and needed. Because every line of code you write is a debt. It's a contract that I'm writing with my teammates, with my customers, and myself. The problem is we write bugs. Almost exclusively, we write bugs, whether it's due to our limited domain knowledge, technical knowledge, or perhaps due to just a simple miscommunications. And there have been quite a lot of talks about the developer quality, productivity, trying to measure that and whatnot. And we do generally have a consensus on what a good code is. And I do agree with this sentiment that the code should be written for human and should be understandable in majority of cases. And good abstractions allow us exactly that. To focus on a higher level detail, to introduce someone to domain, and as you go lower to the abstraction, you get either into more technical details or legislation details. Basically, things are not as important when you're presenting high-level code. And basically, we did product development for quite some time, and about 4 years ago, we started to encode what we learned along the way. So we encoded the patterns and ideas that help us build product faster and safer with fewer bugs. We dealt with stakeholders, their feedback, and we had to adapt the product as usual in the last minute changes, and still we tried somehow to make the customers happy. And the usual question between each product iteration was, can we do something better? Is there a way to do this more elegantly or more performative? Can we improve? Can we work within the constraints of the real world that we're giving? Because the code that you write is usually idealistic, and then the real world hits it. And we basically built an ecosystem of libraries that has helped us achieve that. And one of the things that we basically did is we embraced SQL. Adding SQL is an amazing language for majority of use cases. Adding today that you really need to have a good reason not to use SQL. We primarily focus on progress, and we have a future parity with it. We took a database-first approach, meaning that we use the database and the code in a model as source of truth. And then we use it to generate the model, and basically everything you need in the application code to communicate with a database, whether it's to retrieve some rows for the table, insert, update, and stuff like that. But we basically extended that to the front end. So it basically means that we have our structures and our model SQL, and if we use them in the backend API, the types get automatically propagated to the front end. So all the structs and API calls can be generated. We piggyback on Swagger 2 Open API specification to achieve some of that. And it's like quite liberating. For example, if you have an ID in your code, which obviously should be an identifier, and then you have to integrate it with an external source, which has their own ID scheme in something. And basically, in a language, in the backend code, we define it as a sum type, so it has to, and all the errors are propagated to the front end. So all they have to do is follow the almighty compiler, and once we fix all the error, it usually works, usually. And we needed a language that is capable of expressing such abstract ideas. Perhaps a controversial choice in the beginning was to use Haskell, but it proved to be correct for us so far. So, quick question. Raise your hands if you've played around with Haskell at any point of your life. That's more hands than I expected. Excellent. So, I'm not so old, but I've been doing this for quite some time. And when I initially started dabbling with front-end programming, there was this new thing called Jquery. Perhaps some of you have heard of it. And what I specifically liked about it, that I had no idea what I was doing. Like, I was like simply going to some blog or website, I copied some code, I pasted it in my browser, ran it, and it works. It was like super exciting. And on the time, there was on our website coming up Stack Overflow, which basically I post a question and I get a code that works. Wow, how excellent is that? And this is something that, like interests me in the wrong path, the front end programming, and I liked it. And as you know, like Haskell has all of those stigmas attached to it, which is topic to that can be covered here. It's for a different talk. But if I started to learn JavaScript in the same way, like as actually going through the details of the language, which absolutely make no sense, I would have probably like given up, tried to figure out like some notations or what is this in JavaScript, basically. And this analogy is something that we've been trying to achieve. Like, we want to create a framework which will allow you to be productive and to work against real-world cases, but you don't need to know really sometimes complex stuff that's happening under the hood. If you want to, of course you can, but the idea is to slowly introduce you in the analogy that I use with jQuery and JavaScript. Like as I learn more jQuery and start actually write for the applications, of course I learn a little bit of JavaScript, but the idea is like to be like a gateway to this extremely powerful type system, which eventually becomes like a Goliath on whose shoulder you're standing on when you're going into the battle. It's a really, really powerful thing. And in order to do that, one of the things that we did, we reduced the scope of compilable programs. And what do I mean by that? I mean that we moved like quite a bit of logic and error checking and bug catching to the type level. So we have quite a lot of stuff encoded on the type level. Of course, the obvious sacrifice is that it does increase the compile time. But in our case, it was a sacrifice that we were willing to make. And like, for example, some of the things that we can do is basically like standard thing. If you're using, we can validate if your code will work against a new model that you have just created. Like, is perhaps some field missing? Are you trying to insert a record, which some fields that should be required are not present? Perhaps some fields have been removed. All of this have been manifested as compile errors. Or, for example, we have also encoded a privilege system in which basically if you are in the context of a user and you try to use a function which requires an admin privilege, you'll get a compile error. You cannot do that. If, for example, you have a function which does some logging and it's not supposed to do, you'll get a compile error. This function is logging and it's not supposed to log. And one of the things that we use to do that, they're called effects. So I'm not going to talk too much about effects, because in theory it's basically something it's not needed. But then again, it's not needed in the same sense that lambda calculus and tuning machines are perfectly, enough to write most of the computations. It's basically how much you value composition and abstraction. And we value it like quite a lot. And the effects allow you to write your code correct first. And then you worry with the real world later. So you deal with the performance problems like that, with legislation problems and all the stuff like that. And what they basically do is, I read an excellent one-sentence summary would be they allow you to do reconfiguration of meaning, which is like completely abstract, but I'll show you a couple of examples just to give you like a tangible view. And what is amazing is they allow you to give more context to your functions. So they allow you on a type level to be sure, or when you're looking at your function in a source code, okay, this is what it does. This function is not going to start a nuclear reactor and a new world war. I'm pretty sure that it's going to do exactly what it's supposed to do. And to give you one example would be the thing I talk about. Is so for those of you who are not familiar with Haskell, so you have a function, create user, which takes some user request, which is like an object. You can think of it. It has, I don't know, an email, username, password, and stuff like that, and it returns some user details. But it requires that you're either an organizational admin or an admin. And we have a second function here, for example, get user details, which requires just to be logged in order to retrieve the user details. And what's cool, for example, about this privilege system, if you try to use create user inside get user details, of course, something like that would not be allowed because the compiler will know that you do not have enough privilege to do that. But the opposite is true. Like, if inside the create user function you use get user details, you'll be free to do that because you can build a tree-like structure with your privileges and really explain on a compile level what you want your programs to do. Another real-world example that happened like a couple of months ago. So just to give you a quick context of one of the products that we're building, it's in the food delivery business. And basically, when the restaurants are creating food, they rate like 2 pizzas to location A, lasagna to location B. So you have like 2 orders and they're packaged in deliveries. And a simple problem that we have, like like for restaurant, we want to retrieve a list of all deliveries. And it's all good, except if you use a naive approach, you eventually run into the performance problem, because a restaurant has probably like top 5 meals that everyone orders. And if you're using this naive approach, you're going to retrieve the same information about a gazillion of times. So what do we want to implement? So we wanted to implement a repository pattern between app and a database. And what I mean by that? I mean that we didn't want our application code to always use the database source. We wanted, in some cases where we deemed it's necessary for performance reason, to preload what needs to be preloaded, load it into a memory, and then serve those data much faster. You can see, for example, we have one effect here, which is the database, which of course, as you can guess, allows us to connect to the database and exposes the functions that are needed. And what we basically do, we implement a new effect, which is a product repository, which is in a separate file, completely isolated. It's nothing smart. It basically loads the product for a single organization, stores them in memory, and then retrieving delivery details. The subsequent functions do not connect to a database. They rather load everything from the memory. And as I said, like, this is quite composable. Look, you can add as many effects as you want and use them in extreme cases. Like some of the effects that we have so far, like send mail, push notification, logging, Google Maps, Mapbox. One of the things that I mentioned, just to demonstrate the composability of it, would be the external service effect. So, for example, Google Maps and Mapbox, of course, if you use them, you know how their pricing models work. You basically pay by request. And we wrap those effects with an external service effect. And it means that every call we make to the services automatically gets logged. So you can have like nice analytics for effects that we want with the information that we want. So it's pretty cool to use. And what we built so far. So our first library and the main entry point was Data Basic, which is database library with a code first approach. So it does everything you would expect from a database library. But eventually, since we took the code first approach, we started to run into some limitations to what SQL functionality was exposed to us. So about 2 years ago, we decided, okay, like this is simply the bottleneck currently in the development. We cannot support all the features from the SQL we want. So we had to write our own semantic SQL compiler and parser. And what I mean by semantic, I mean that we actually, when we parse your schema with foreign keys and whatnots, we actually get a representation of a schema in our code, which means that we have like a query-like language, meta language, for which we can ask the database, okay, how many tables does it have? Does this column have a primary key? Is this like column unique? And stuff like that. And then we use that information to generate the code that is needed for the backend. It's like, as I said, currently we support PostgreSQL, but we had like modularity in our architecture from the first day. So it can be easily extended much further. We have simple effects, which are exactly how it sounds. They allow you in a simple and a user-friendly way to define the abstraction that I'm talking about. There's quite a lot of stuff and boilerplate going on in the actual library, which we simply do not want to expose to the users. If you've coded in Haskell for quite time, you've heard the concept of monad transformers and something like that. This is horrible. Like, I never want to work with something like that. And one of the things, when I started working on it, told my colleague, like, we need to figure this out. Like, this is not going to work. Because it's simply, like, too impractical. And the effects abstraction is something that solved this quite nicely. We have a starter kit, which combines all of this in a fully functional, like, a project which you can basically clone and start working at. It depends on servant library for the HTTP stuff. And it gives you out of the box like quite a lot of stuff. So for example, one of the things you have is mock API. So you write your types and you can expose it to your front end. Like no actual, like coding as logic needed. You can just put undefined. Of course, the value that will front end get may not make sense, or actually probably will not make sense, but it's still like, it solves the problem like where the backend is the bottleneck because, the front end is waiting for some feature to be finished before he can start working on it, and quite a lot of other stuff. We have started working on it in a prototype phase now on a command line interface. Basically, we want to work quite a lot on the developer experience here. We want to have a tool which is going to pull up all dependencies and set up the project for you. So you can easily start the development environment. You can easily build a production environment. You can easily add new pages and whatnot. Excuse me. But there's still like a long, long way to go. One of the things that we are going to be working in the next year, we are going to slowly prepare for a public release. And one of the things we have to do a rebranding. Because you can imagine Basic is probably not the most search engine friendly name. So we're going to work on that. We're going to work on a web page, and we are extensively working on user documentation. So we have some alpha testers, basically, where we introduce them to the framework without prior knowledge, and we see what problems do they encounter. We'll try to document all the common errors that are happening to show the users how to move forward. The Elm compiler was an excellent inspiration for that because it really solved that problem quite well. We, of course, are going to broaden the scope of available effects. We have quite a lot, but this thing is never going to be enough. We're still going to improve the CLI tool for even better developer experience. As I said, it's in prototype now, quite a lot of stuff to do. And one of the things that probably most excites me, but it's still like quite a lot unexplored, is the backpack. It's the plugin-like system. It's to the library what the code is to the library. So it's basically an abstraction above a library. A good example would be if you want to work with hash maps or dictionaries. Backpack will allow you to write a single interface to tell other libraries what they need to implement in order to use their interface. And it will allow you to test out different implementations of HashMap, because there's quite a lot of them, and you can swap them out with basically with a change of a dependency. And it's something that we are exploring right now. Is going to take like quite a lot of work, but eventually something like that can even be extended to an app marketplace. And as I said, there's still a lot of work to done, which I hope to share with you in the near future. Now would be a perfect time to ask any questions, and hopefully ones that can be answered quite quick. And if you have any detailed questions, feel free to approach me anytime, because obviously I love talking about this stuff. Or here's my email, shoot me an email anytime.
Thank you, Nikola. Questions? Okay.
Hi, I'm George from Austria, and just one question. If I got it right, and just correct me, it is somehow very similar to an object relational mapping tool that you have. So I'm quite branded with this topic, so why do you think that your approach, which I think maps functional calls to relational world, is a good approach?
Well, I don't think that the approach per se is the solution. I just hope that with work we're going to simply inspire more exploration in the space, because I think that currently, especially in the ecosystem we are working on, those ideas are underdeveloped and they need more attention.
I have two. Oh, okay. Yeah, thanks. Is it going to be open source? Is it going to be open source? Was the license? And,
yes.
You didn't
MIT
mention
license.
That. You didn't mention. And the second thing is, how did you solve the very blatant impedance mismatch between Haskell's and Helm's type systems? The impedance mismatch between Haskell's type system and Helm's type system, which is very, very, very big.
Yeah. We actually try to limit ourselves in the types that we actually expose to the front end. Simply because the usual approach is you do expose the data from the database directly, and then you realize, oh, but I really need all that information. Oh, I need to populate this object with additional information that is not available at a table. So at the end, what do? We have like a request and response types basically, which we then integrate with Elm.